To reduce embodied carbon, the best way is to start with data, and EPDs give us a recognised international format for comparing construction products. The challenge with EPDs though is that whilst the information is in one standard format, it can often be slightly misleading. Here's why. The scope can vary, the life cycle stages which are being declared can vary, and thirdly, the assumptions can affect it quite significantly. So using balconies as an example, an EPD might have a declared unit on it, but that can differ. For example, the materials of a concrete balcony might be declared as 1 6 square metre balcony, but does that contain the complete structure? A concrete balcony might just be the concrete deck, the cassette of the balcony itself, not all the other components. A 6 square metre in itself may also be misleading, and the reason being is we talk about 6 square metres in multiple different ways, and it will depend on the construction component. With balconies, for example, the difference we get is usable area versus the footprint. So usable area is the area we can stand on, and that really is the main terminology which we talk about when we refer to things like the London Plan. However, the footprint of the balcony, of a 6 square metre balcony, is more like 6.5 square metres. So to be able to compare accurately, we need to understand what is the actual component and what is the scope and what is included within that scope of the balcony. So the second area is life cycle stages. We're normally looking for embodied carbon at A1 to A3 or A1 to A5. It's really important that we understand what is and isn't included in those stages. The reason being is accidentally, or maybe it suits commercially, sometimes components will be moved into a different stage. So for example, with a balcony, are the arms in the cassette balcony, are they specifically excluded, or are they actually in A5 because that's where they get fitted, even though that's probably not where they should, strictly speaking, be sitting. So it's important to understand these life cycle stages when we're looking at the embodied carbon of a balcony or any construction product. A great EPD should specifically give clarity on the assumptions made and why certain things have been made that way. So for example, it's really important for us to understand, have we taken data points which are actually standard in the industry, or have we taken data points which give us the best possible result? Because that may not reflect reality. So assumptions are really important for us to understand, and a good EPD should give you real clarity. The declared unit should have exactly what it is in the EPD, and should perhaps even specify what the usable and the total footprint area of balconies are. Assumptions are a really critical piece to make sure that we're not comparing things accidentally different from one another. So in summary, EPDs are a great source of information, but make sure that you understand the scope and that the scope reflects what you want, that the product life cycles are relevant and that things are in the right stages or are being compared like for like, and thirdly, that any assumptions are clearly understood and documented before you start trying to reduce the carbon based on that EPD and information.